Hi, welcome to this video. I'm Emily Wong from emilylearning.com. So in this video, I'll be going through the Cambridge iGCSE paper 4. So this is a paper on structured question and it is on the extended syllabus. So the paper that we are going through will be the May-June 2022 paper. So let's get started. So now let's take a look at this. A list of substance is shown. So we have a list of these substances shown. Answer the question using the list of substances. Each substances may be used once, more than once, or not at all. State which of the substance. Okay, so you can use all these more than once or you don't use them at all. So let's take a look at the questions and answer them. So state which of the following substance is a reactant in photosynthesis. So in photosynthesis, the plants make use of carbon dioxide and water, okay, in the presence of sunlight to make glucose. Okay, oxygen is also produced at the same time. So the reactant in photosynthesis is basically carbon dioxide as well as water. So yes, there is carbon dioxide. So the answer here will be carbon dioxide. Moving on to B, what is the main constituent of bauxite? So this is under the chapter on electrolysis. So the aluminium is obtained, or we extract aluminium from its ore, which is bauxite, and bauxite is made up of aluminium oxide plus many other impurities. Okay. Next, you are asked for two products of fermentation. So in fermentation, ethanol, okay, undergoes fermentation to give carbon dioxide as well. In fermentation, glucose, okay, undergo fermentation to produce ethanol. Carbon dioxide is also produced at the same time. So the two products of fermentations are both ethanol and carbon dioxide. Next, D, what is used as a fuel? So there are many possibilities. As long as you have something that can burn, it can be used as a fuel. So in this case, right, the one that we have is ethanol here. So organic compounds can be used as fuels. Next, E is a gas used to convert iron into steel. So we use to convert iron into steel, we actually need to dope things in, okay, and we'll be using oxygen to convert iron into steel. This one is basically memory work from the metals chapter. Next, what is a greenhouse gas? So carbon dioxide is a greenhouse gas. Greenhouse gas are basically gases, right, that can absorb heat to keep the earth warm. But when we have too much of it, it actually makes the earth extremely warm. It results in global warming. Next, G is a gas that is approximately 78% of clean dry air. So it is nitrogen. Nitrogen is the largest constituent in air. What is a form of carbon? Diamond is a form of carbon, just like graphite. Okay, so we have completed question 1. Moving on to question 2, atoms are made of protons, neutrons, and electrons. Atoms of the same elements are known as isotopes. So isotopes, what are isotopes? Isotopes are basically elements of the same atoms with the same number of protons but different number of neutrons. Right, so these are isotopes. So now let's come back to this question. So you're asked to complete the table on relative charge and mass of your particles, which are your electrons, neutrons, and protons. So we know that electrons has a charge of -1, while proton has a charge of +1, and neutrons are neutral, so they have a charge of 0. Okay, the relative mass of an electron is 1/1840. The relative mass of a proton is 1. Okay, and the relative mass of a neutron is 1. So whenever we compare mass, we compare the mass of protons or neutrons to 1/12 the mass of one atom of carbon 12. Alright, so just remember that relative mass of neutron and proton is 1. All right. Next, let's move on to part 2. So, so you are given 2 isotopes of magnesium. So you know there are 2 numbers. The number on top is the mass number, and the mass number tells us the number of protons plus neutrons. The number at the bottom here, 12, okay, for both of them is the number of protons. So because they are isotopes, right, they will have the same number of protons. Okay, the only difference lies in the number of neutrons. Okay, so the top number tells us number of protons plus neutrons. So to find the number of neutrons, you will take the number on top minus the number below. So now let's take a look at this question. They ask us to complete the table to show the number of electrons, neutrons, and protons in the isotopes of magnesium. So in magnesium 24, we know that the number of protons is 12 because the number at the bottom gives the number of protons. To find the number of neutrons, you will take the top number, which is 24, minus the bottom number. So 24 minus 12 is 12. Number of electrons is equals to number of protons for an atom, so it will be 12 as well. So for magnesium 25, the number of protons is 12. Okay. The number of electrons is also 12. To find the number of neutrons, you will take the top number, which is 25, minus the number below, which is 12. So 25 minus 12 gives us 13. Okay. Moving on to part 3, explain why magnesium has a charge of +2. Okay. So what you need to say, you need to explain a charge of +2. So talk about the magnesium. Okay, when magnesium forms ions, it loses 2 electrons. Okay, since there are two more protons than electrons, magnesium ion has a charge of +2. Okay, so key thing, right, if you want to explain that something has a charge of 2+, the key word is the number of protons is 2 more than the number of electrons. Okay, or the number of electrons is 2 lesser than the number of protons. Okay. Next, let's take a look at B. Magnesium ion has the electronic structure of 2,8. Give the formula of the following particles which has the same electronic structure as Mg2+. So you want a cation ion that has an electronic structure of 2,8 and an anion that has an electronic configuration of 2,8 and an atom that has an electronic configuration of 2,8. So to do so, we need to take a look at the periodic table. So let's go to the last page where the periodic table is located. Okay, so this is magnesium. So we are told that for Mg2+, what do we have? Well, for Mg2+, we have electronic configuration of 2,8, right? Okay, so what you'll notice is that in the same period, so your sodium, magnesium, and aluminum, in the same period, all these will form ions with the same electronic configuration. So Al3+ will form an ion with an electronic configuration of 2,8 because aluminium has 13 protons. In other words, its atom has 13 electrons. So to form Al3+, it will lose 3 electrons. So it is left with 10 electrons. So 10 electrons will be 2,8. So if you have 10 electrons, the electronic configuration will always be 2,8. Same thing, sodium, once it forms ions, okay, it will have an electronic configuration of 2,8. So because the number of electrons in sodium atom is 11, so to form ion, it will lose one electron. So now it has 10 electrons. So the electronic configuration is 2,8. So just remember that, right? If you want to look for ions with the same electronic configuration for metals, okay, it will be in the same period. Right? Then for anions, right, it will be the period before it. So what I meant is, for example, we are looking at this. Okay, so for nitrogen, so remember for non-metals, they gain electrons. So how many electrons do they gain? So nitrogen is in group 5, so it has 5 valence electrons. So it will gain 3 electrons to achieve its stable octet configuration. So after gaining 3 electrons, it have 10 electrons. So N3 minus will have an electronic configuration of 2,8. Similarly, oxygen, okay, it has 6 valence electrons, so its atom has an electronic configuration of 2,6. Okay, so in order to achieve stable octet configuration, it will gain 2 electrons to form 2,8. Okay, or it gains 2 electrons to have 10, so it will be O2 minus, and its electronic configuration is also 2,8. Same thing for fluoride, F minus have an electronic configuration of 2,8 because 9 electrons in the atom, it gains 1 to get 10. Then for 10 electrons, the electronic configuration is 2,8. For neon, because it is a noble gas, doesn't need to gain any electrons, its electronic configuration is 2,8. So in other words, right, magnesium has the same electronic configuration, or magnesium ion has the same electronic configuration as sodium and aluminum ions, neon atom, and nitrogen, oxygen, and fluoride ions, or nitrite, this is called nitrite ion, oxide ion, and fluoride ion. I do have a blog post on all these, so I'll put it in the link in the description below for you to take a look at it if you need more practice on electronic configurations for O-level or GCSE. All right. Okay, so now that we know that magnesium ions, sodium ions, and aluminum ions have the same electronic configuration, okay, and neon atoms, neon atom has the same electronic configuration of Mg2 plus, N3 minus, O2 minus, and F minus have the same electronic configuration as Mg2 plus. Let's go back to the question that we have. Okay. Okay, so if you need to give the formula of the following particles which has the same electronic structure as Mg2 plus, so a positive cation, you can either write sodium ions or aluminum ions. Any one of them will be correct. You just need to write one of it. And N ions, so it will be N3 minus, O2 minus, or F minus. Write any one, okay? Any one of these three will give you the correct answer. Okay, and the atom is neon. Okay, so this is the answer for B. Okay, next, moving on to question 3. This question is about sodium and compounds of sodium. So describe the bonding in metallic elements such as sodium. You may include a diagram as part of your answers. So basically, when sodium is a metal, it is metallic bonding. So you need to talk about metallic bonding, which is a positive ions in a sea of delocalized electrons, and the metallic bond is the attraction between the positive cations and the negative electrons. Okay, so that is how you get your 3 points. So you need to talk about metallic bonding consists of positive ions or cations in a sea of delocalized electrons. Okay, the bonding is the attraction between the cations and the negatively charged electrons, delocalized electrons. Okay, so they say you may include a diagram. If you write this, you do not need to include a diagram. If you want to include a diagram, then what you could draw is you could draw this, the positive cations. Okay, they should be of the same size, okay? So you have your sea of delocalized electrons here. Okay, then you need to let people know what you're drawing. So you just write a symbol. So this will be positive ions. And this one is your delocalized electrons. Okay, Then after you have drawn this, you still need to talk about the attraction between the cations and the negatively charged delocalized electrons is the metallic bonding to get all your 3 marks. Okay, so for just note that if they ask you to include, you may include, that means you can include, you can don't include, as long as what you have written is clear enough, you do not need to draw. Okay, but if you want to draw, this is what you need to draw, and you also need to state that the metallic bond is the attraction between the delocalized electrons and the positive cations. Okay, next, part 2, describe how solid sodium conducts electricity. So it is just 1 mark. So you need to basically just talk about the mobile electrons allows it to conduct electricity. Mobile electrons, okay, allows sodium to conduct electricity. So basically, right, if they ask how does something conduct electricity, what you need to talk about is what charged particle can move, okay? Or what charged particle is mobile. So for metals, it is the electrons that are mobile, okay? So therefore, it conducts electricity. For ions, right, it is the ions that are mobile that conduct electricity, and ions are only mobile in the liquid, in the aqueous, or in the gaseous phase, okay, not in the solid phase. That is why ionic compounds do not conduct electricity in the solid state. Next, let's look at part B. Some properties of sodium chloride are shown. So we know that it has a melting point, high melting point, because it's 801 degrees Celsius, non-conductor of electricity when solid, conductor of electricity when molten, and soluble in water. So name the type of bonding in sodium chloride. So sodium is a metal, chlorine is a non-metal. Metal and non-metal forms ionic bonding due to the transfer of electrons from sodium to chlorine. Okay, so it is ionic bonding. So next, explain why sodium chloride conducts electricity when molten. So you need to talk about what can move, what charged particle can move. So you talk about when molten, the ions are free to move about to conduct electricity. All right, so that is why. So because the ions can move when molten, or molten means liquid state, so therefore ionic compounds like sodium chloride can conduct electricity when molten. Moving on to part C, a student determines the concentration of solution of dilute sulfuric acid by titration with aqueous sodium hydroxide. Okay, so these are the titration steps. Okay, so firstly they add 25 cm cube of 0.2 mol per dm cube sodium hydroxide is transferred to a conical flask. Then you add 3 drops of methyl orange. Okay, so when you add 3 drops of methyl orange to sodium hydroxide, it will turn yellow, right? Next, you fill a burette with H2SO4. Then you add the acid in the burette is added to the conical flask until the indicator changes color to orange. So therefore, you know that the titration is complete. The volume of acid is recorded. This process is known as titration. The titration is repeated several times until a suitable number of results is obtained. So next, you are asked, name the piece of apparatus used to measure exactly 25 cm cube, okay, of 0.2 mol per dm cube sodium hydroxide in step 1. So you'll use a pipette to measure accurately 25 cm cube. Next, they ask state the color change of the methyl orange in step 4. So initially your methyl orange was placed in sodium hydroxide. Okay, sodium hydroxide is alkaline. So when methyl orange is alkaline, it is yellow. So initially at step 1, the methyl orange is yellow. Okay, yellow. Then when the titration is completed, okay, the methyl orange will change from yellow to orange to show that the titration is completed. That means all the sodium hydroxide is completely neutralized. So the answer is yellow to orange. Next, state how the student decides that a suitable number of results have been obtained. Okay, so in order to obtain suitable results for your titration, you need your readings, and the readings cannot be too far off, right? So you need to have at least 2 results that are within around 0.2 cm cube or less to each other, so that you know that, okay, I have repeated and I've get consistent results. So these consistent results are the one that I will choose. All right. So the answer is at least 2 results are within 0.2 cm cube or less. Okay, so wait. So I need to put in my cube here. So for burette readings, right, for titrations, as long as you have 2 or more readings that are within 0.2 cm cube or less, okay, it is suitable and can use them, okay, for your titration results. You need to find the average though, okay. Next, 20 cm cube of H2SO4 reacts with 25 cm cube of 0.2 mol per dm cube NaOH. The equation is given. So calculate the concentration of H2SO4 using the following steps. So first step, they give you all the steps already. So the first step, they ask you to calculate the number of moles of 25 cm cube of 0.2 mol per dm cube NaOH. And in order to find the number of moles of NaOH, you will take concentration times volume in dm cube. So to change cm cube to dm cube, you will divide by 1,000. Okay, and this will give us 0.005 moles. Next, determine the number of moles of H2SO4 that reacts with sodium hydroxide. So to determine the number of moles that has reacted given the equation, you will make use of mole ratio. So from this equation here, we know that 1 mole of H2SO4 will react with 2 moles of NaOH. So the mole ratio is 1:2. So if there is 0.005 moles of NaOH that is being used, then the number of moles of H2SO4 will be 0.005 divided by 2. So the number of moles of H2SO4 is 0.005 divided by 2, which is 0.0025 moles. Okay. Next, you are asked to calculate the concentration of H2SO4. So we know that concentration in mole per dm cube is equals to moles over volume in dm cube. So to find the concentration, I simply need to take the number of moles of H2SO4, which is 0.0025, divide by the volume, which in this case is 20 cm cube. But remember, because I want concentration in mole per dm cube, I need to change 20 cm cube to dm cube by dividing it by 1,000. So this is 20 over 1,000 dm cube. Okay, so to find concentration of H2SO4, I will take 0.0025 divided by 20 over 1,000. Okay, and this will give me 0.125 moles per dm cube. So the answer is 0.125 moles per dm cube. Moving on to question 4. So this question is about sulfur. So this is under the chapter on sulfur manufacturing of sulfuric acid through the contact process. So let's look at this. So you are given sulfuric acid H2SO4 is manufactured using the contact process. The manufacture involves 4 stages. So you burn sulfur in the air to produce sulfur dioxide. So S plus O2, you form SO2. Then sulfur dioxide reacts with more oxygen to form sulfur trioxide, okay, in stage 3. Then next, sulfur trioxide combines with concentrated sulfuric acid to form oleum. So SO3 plus H2SO4, you'll form H2S2O7, which is your oleum. Then you add oleum, okay, to water to form sulfuric acid. Okay. So now you're asked to write the equation for the reaction occurring in stage 1, which I already written. S plus O2, you form SO2. Next, you need to state the essential conditions that are necessary for stage 2. Write an equation for the chemical reaction that occurs. So you need to talk about the temperature, the pressure, and the catalyst used, and also for the equation. And this is a reversible reaction. Okay, so you need a temperature of 450 degrees Celsius at an atmospheric pressure of 1 to 2 atmospheres. Okay, and you will use vanadium 5 oxide as a catalyst. So writing all this will give you 3 marks. To get the 4th mark, you need to write the equation, okay, which is this. Next, write a chemical equation for the reaction occurring in stage 3. So basically it's this that I've written. Okay, and step 4, name the substance that reacts with oleum in stage 4. So basically that substance is water. You add water slowly to oleum to form H2SO4. Okay, moving on to part B. Okay, so part B, you're asked to complete the dot and cross diagram to show the electronic arrangement in the molecule of hydrogen sulfide. Show outer shell electrons only. So we know that hydrogen has 1 outer shell electrons. Sulfur is in group 6. Check your periodic table. So you know that it's in group 6, so it has 6 outer shell electrons. Okay, so if it has 6 outer shell electrons, it lacks 2 more to achieve stable octet configuration. So in order to achieve stable octet configuration, it will put 1 electron in, and hydrogen will share another 1. Okay, then the other 4 electrons are not shared, so they are outside. So this is the dot and cross diagram to show the electronic arrangement of hydrogen sulfide in the molecule. I will put a link to the drawing of dot and cross diagram for more information if you are interested. I do have a complete blog post on this. Alright, now moving on to the next portion. Okay, we are asked to balance the chemical equation for the reaction of hydrogen sulfide with sulfur dioxide as shown below. So you know that there are 2 S here, so I'll put the reactants and products must have the same number of each type of atoms. So 2 S here, 1 S here, 1 S here, so there are 2 S here, so I'll put 2 here. Alright, then but I know that I have 2 oxygens, so I need 2 here. So once I have 2 oxygen here, I have 4 hydrogens. So in order to have 4 hydrogens, I need to put 2 here. So at the end of the day, I end up having 3 sulfur. So this is not 2, this should be 3. So now let's check whether we have the same number of H, S, and O at both sides of the equation. So on the reactant side, I have 2 hydrogens, 2 sulfur, and 3 sulfurs and 2 oxygen. For the product side, I have 2 hydrogens, 3 sulfurs, and 2 oxygen. So yes, it is a balanced equation because the number of atoms on both sides are the same. Moving on to question 5, ethanoic acid is manufactured by the reaction of methanol with carbon monoxide, and they give us this equation here. State 2 characteristics of an equilibrium. So basically this is asking you to define what equilibrium is. So equilibrium is basically reached when the rate of the forward equation is equals to the rate of the reverse reaction, and the concentration of the reactants and products remain the same. So you need to write this, and this one is basically definitions of equilibrium. So the rate of the forward and backwards or reverse reaction are equal, and there is no change in the concentration of the reactants and the products. Okay, or the concentration of the reactants and the products remain constant. Okay, next, the purpose of the industrial process, this industrial process, is to produce high yield of ethanoic acid. This is ethanoic acid at a high rate of reaction. The manufacture is carried out at 300 degrees Celsius. The forward reaction is exothermic. So this is an exothermic reaction. Okay, use the information only to state why the manufacture is not carried out at temperatures below 300 degrees Celsius. Well, we know that this is an exothermic reaction. So in order to favor you, you're like low temperature, right? Low temperature favors U of ethanoic acid. This is ethanoic acid, all right? Okay, because it's exothermic, so the lower the temperature, the more the position of equilibrium shifts to the right, the more the amount of ethanoic acid is formed. But we do not want too low a temperature, because when the temperature is low, the rate of reaction is slow. Okay, so the reason why you don't want it below 300 degrees Celsius is because, okay, reaction is too slow. And you do not want a temperature above 300 degrees Celsius is because the yield of ethanoic acid will be too low. because the higher the temperature, the lower the yield of the forward reaction, or the lower the yield of ethanoic acid. All right, so you need to choose a moderate temperature. In industries, 300 degrees Celsius is considered lower, right? So you need to choose a moderate temperatures for the reaction so that you can get sufficient yield at not too slow a reaction rate, and that is why they chose 300 degrees Celsius. Next, complete the table only using the word increase, decrease, or no change. So adding a catalyst, you have no change on the equilibrium of. So adding a catalyst, you have no change on the equilibrium yield, okay? Because a catalyst will increase the rate of the forward and the backwards reaction by the same amount. Okay, so effect on the rate of the forward reaction, it will increase. Okay, so does the rate of the backward reaction. So therefore, at the end of the day, the amount of CH3, COOH, or the amount of ethanoic acid that you get remains unchanged with the addition of a catalyst. Next, let's look at decreasing the pressure. So when we are looking at pressure, we will need to look at the number of moles of gas. So in this reaction, it involves 2 moles of gas atoms forms 1 mole of gas atoms. So the reaction by itself will decrease the pressure. So if you want the equilibrium to shift to the right, you increase the pressure, because a high pressure will favor the reaction that produces less gas molecules, because less gas molecules will decrease this increased pressure. So if you were to decrease the pressure, what happens is you are going to shift the reaction backwards, okay? Because the backward reaction will be favored by a lower pressure. So decreasing the pressure will reduce the equilibrium. Okay, so let me write decreases here. Okay, and whenever you decrease the pressure, the rate of reaction will be decreased. Okay, reason is because now the particles are further apart, so the frequency of effective collision between reacting particles decreases. So therefore, the rate of reaction decreases. Next, moving on to D, suggest which of the following methods is a suitable catalyst for the reaction. Give a reason for your answer. So we did not learn this reaction in your syllabus, your iGCSE syllabus, but we do know that if we want a catalyst, we will probably choose something in the transition metal group. So if you have to look at aluminium is in group 3, calcium is in group 2, cobalt is a transition metal, magnesium is in group 2, potassium is in group 1. So the suitable catalyst is going to be cobalt, because transition elements make good catalysts. So you talk about cobalt is a transition metal, and transition metal or elements make good catalysts. All right, okay. Okay, so that's the answer for D. Moving on to E, ethanoic acid is a member of the homologous series of carboxylic acid. State the general formula of this homologous series. So if we are looking at the carboxylic acid, the general formula is CnH2n plus 1 COOH. Okay, and remember the n starts from 0. Okay. Draw the structure of the carboxylic acid containing 3 carbons. Show all the atoms and all the bonds. So if you want a carboxylic acid containing 3 carbon atoms, then n will be 2, because there's 2 carbons here plus 1 carbon here, total is 3. So when n is 2, you have C2H5COOH. So 2 plus 1, 3 carbon altogether. So next, let's draw the structure of the carboxylic acid containing 3 carbons. So to do so, always start off by drawing the carboxylic acid group. So you have your COOH. Next, put in the other 2 carbons. And then remember, all carbons need to have 4 bonds. So complete these bonds with hydrogen. So this is the structure of the carboxylic acid that contains 3 carbons. And this carboxylic acid that contains 3 carbons is basically your propanoic acid. Okay, moving on to the next one. So when carboxylic acid reacts with alcohols, esters are produced. The formula of the ester is CH3, CH2, CH2, COO, CH3. So if you look at this COO, CH3, this is basically COO. Okay, then this is CH3. Maybe I should write it here. Okay, let me change the color to red. Okay, so this is COO, so this is COO. Then let me put in the CH3 here, and let me put in the CH3, CH2, CH2, CH3, CH2, CH2. All right, so now you're asked to name ester X. So whenever you name the ester, right, it is always something YL, followed by OATE. So the YL part is contributed by the alcohol portion, and the OATE part is contributed by the part that comes from the carboxylic acid. So the part that contains the C double bond O comes from the carboxylic acid, and the part that contains the single bond O came from the alcohol. So we'll start off by the alcohol part. So from the alcohol part, it only has one carbon. So one carbon is methyl. So it is methyl. So it comes from methanol. So it's just one carbon. Next, the acid part has 4. 1, 2, 3, 4. Don't forget to count the C double bond O. The C from the C double bond O is also a carbon. So there are 4 carbons from the carboxylic acid. Okay, so this 4 carbons is butanoic, right? So this portion here came from butanoic acid. So when you name the ester, the acid part will become O8. So it's butanoate. Okay, so this ester X is called methyl butanoate. Next, you are asked to give the name of the carboxylic acid and the alcohol that react to produce ester X. So we know that the alcohol is methanol, and the carboxylic acid is butanoic acid. All right. Okay, next, let's look at this. Ester Y has the following composition by mass. So your carbon is 48.65%, hydrogen is 8.1%, O is 43.24%. You're asked to find the empirical formula of ester Y. So to do so, we usually use a table form, right? So let's set up the table for this. Okay, so now I'll start off by doing this. So I'll write C, H, and O. And the first row will be percentage composition. So the carbon is 48.65, H is 8.11, O is 43.24. Then next is number of moles per 100 gram. So you can think of it as this is basically if the percentage composition is 48.65%, that means in every 100 gram there's 48.65 grams of carbon. Percentage composition of hydrogen is 8.11, so every 100 gram there's 8.11 grams of hydrogen. Percentage composition of oxygen is 43.24, so every 100 grams there's 43.24 grams of oxygen. So now that you know these, right, okay, you need to find number of moles, and number of moles is basically mass over molar mass. So to find the number of moles of carbon, you just take 48.65 divided by 12. 12 is the mass of carbon. So let me show you in the periodic table. So you take the mass number of carbon, okay, which is, so you look at carbon. If you are interested in the molar mass or the relative atomic mass, you take the bigger number, which is 12. So for carbon, it is 12. For hydrogen, the relative atomic mass is 1. And for oxygen, the relative atomic mass is 16. So this is what we are going to put inside, okay? So let's go back to the question here. Okay, so we have 48.65 divided by 12. Then you have 8.11 over 1. And 43.24 divided by 16. So let me type everything into the calculator. Okay, so now that I have found these values here, next I will divide. I'm interested in the ratio of C is to H is to O. So to find the ratio, I'll divide by the number of moles of the smallest number. So I know that the number of moles in 100 grams of ester Y. Okay, the number of moles of carbon in 100 grams of ester Y is 4.054. Number of moles of H is 8.11. Number of moles of O is 2.703. So I want a mole ratio. So I'll divide everything by 2.703, which is the smallest number out of these three. So mole ratio, okay, will be 4.054 over 2.703. Okay, then this one is 8.11 divided by 2.703. Then here is 2.703 over 2.703, which is 1. Okay, and here I get, let me take 8.11 over 2.703. It's around 3. Okay. It's roughly 1.5 here. Okay, so when you have 1.5 or something that's close to 0.5, you'll leave it as 0.5. So if you have 1.4 something, just round it off to 1.5. If you have 2.5 or 2.54321 or something like that, just if it's close to 0.5, leave it as 0.5. Okay, you don't round up or down. Okay, if not, you'll make a very big difference. So because it's 1.5 is to 3 is to 1, you multiply everything by 2. So the ratio is 3 is to, so 1.5 times 2 is 3, 3 times 2 is 6, 1 times 2 is 2. So the empirical formula will be C3H6O2. So the empirical formula is C3H6O2. All right. Okay. So next, we have this ester Z has the empirical formula C2H4O and a relative molecular mass of 88. So determine the molecular formula of ester Z. So the empirical formula is basically the simplest whole number ratio of the different elements. Okay, the number of atoms of each element in the formula. Okay, so the relative or the molecular formula tells you the exact number of each, the number of atoms of each element in one molecule. So we know that the molecular formula of Z, so we let the molecular formula of Z be C2H4ON. So where N is an integer. So the molar mass of Z will be equals to 2 times 12 plus 4 times 1 plus 16 times N. Okay, so how did I get 12? So basically the the atomic mass of each carbon is 12. So 2 of them will be 2 times 12. The relative atomic mass of hydrogen is 1. So 4 hydrogens will have a relative atomic mass of 4 times 1. Okay, and the relative atomic mass of oxygen is 16. So add them up, I have, hold on, 24 plus. So I'm basically typing this entire thing into the calculator. I get 44. So the molecular mass is 44. Okay, and there's an N outside, so it's 44N. And I'm also given that the relative molecular mass is 88. So I know that 44N is equals to 88. So I solve N by taking 88 divided by 44, which gives me 2. So therefore, I know that the molecular formula of Z is basically C2H4O2, which is the same as C4H8O2. So the molecular formula is C4H8O2, right? All right, now let's move on to question 6. So in question 6, zinc is extracted from its ore, which is mainly zinc sulfide, ZnS. So these are the steps. So your zinc sulfide is converted to zinc oxide first. Then the zinc oxide is reduced to zinc in a furnace. The zinc forms a gas. The zinc gas is cooled to form molten zinc. Okay, so sixth part, why you're asked to name the ore of zinc, which is mainly zinc sulfide, and this ore is called zinc blende. Okay. Next, describe how zinc sulfide is converted to zinc oxide in step 1. So basically, you heat zinc sulfide in air, okay, to form zinc oxide. So by heating zinc sulfide strongly in air, or you can say roasted in air as well. Next, name the reducing agent used in step 2. So in step 2, you are going to convert zinc oxide to zinc. Okay, and the reducing agent we usually use is either carbon or carbon monoxide. So write either one, you'll get your 1 mark. Okay, you write either carbon or carbon monoxide. Next, explain why the zinc forms a gas in step 2 inside the furnace. So why is something a gas? Well, it is a gas when the temperature inside the furnace is above its boiling point. So the reason why zinc forms a gas in step 2 is because the temperature inside the furnace is above the boiling point of zinc. Next, state the name of the physical change occurring when zinc gas is converted to molten zinc. So from gas to molten or from gas to liquid, it is called condensation. So this process is called condensation. Okay, B. Zinc sulfate crystals ZnSO4.7H2O are hydrated. Okay, so you have your water of crystallization. These molecules are called molecules of crystallization. So they are attached, okay, to your ZnSO4. So ZnSO4 or zinc sulfate crystal are made by reacting zinc carbonate with dilute sulfuric acid. So this is the overall process. So zinc carbonate plus H2SO4 plus 6H2O, you get this. Okay, so you'll get carbon dioxide and salt plus water. Okay, so this is basically your acid base reaction chapter. So zinc sulfate is a soluble salt. So to form it, you add excess insoluble carbonates, oxides, hydroxides, or metal if the metal can react with the acid and it's not too vigorous either. Okay, you add excess of this, okay, to form this salt. Okay, so let's take a look at the steps that are given. So in step 1, you have large pieces of zinc carbonate are added to sulfuric acid until zinc carbonate is in excess. This forms zinc sulfate. Okay, so you have a zinc sulfate solution. Carbon dioxide is liberated, so it will not be inside the solution. Okay, so you separate the excess zinc carbonate from the aqueous zinc sulfate. So excess zinc carbonate is a solid. So to separate it from aqueous zinc sulfate, you'll use filtration. Step 3, the aqueous zinc sulfate is heated until a saturated solution is formed. Then you cool the saturated solution to allow it to crystallize, and then you remove and dry the crystals. So in step 1, zinc carbonate is in excess when no more zinc carbonate dissolves. State one other observation that indicates that the zinc carbonate is in excess. So in other words, they ask you, how do you know that the reaction is complete? All your acid has reacted. Well, one of it is when you see zinc carbonate in excess. The other one is when you do not see any more effervescence, because in this reaction it produces carbon dioxide, and carbon dioxide is a gas. So as long as there's a reaction, you'll see effervescence of carbon dioxide being produced. So when there's no more bubbles of carbon dioxide or there's no more bubbles being observed, that means the reaction has stopped. Okay, so the answer will be when no more bubbles are produced. Next, name another substance other than zinc carbonate that can be added to sulfuric acid to produce zinc sulfate in step 1. So recall I mentioned that this zinc sulfate is a soluble salt. So to form a soluble salt, you add excess insoluble substance to react with the acid. And what reacts with acid? So for zinc, your zinc carbonate, your zinc oxide, your zinc hydroxide, as well as your zinc metal can react with acid. Okay, and these are all insoluble, so they can react with your acid. So basically, your answer for here will be either zinc oxide, or you can write zinc hydroxide, or you can also write zinc metal. Any one of these three will be the correct answer. Moving in part 3, step 1 is repeated using zinc carbonate instead of large pieces. So when you use zinc carbonate powder instead of large pieces, okay, and all conditions are kept the same, the rate of reaction will increase. So they ask you to give a reason why the rate of reactions increase. Explain your answer in terms of particles. So basically, just talk about so you talk about the powdered zinc carbonate has a larger surface area than the large pieces. So you will have more collisions per unit time, or frequency of collisions between reacting particles increases. Okay, therefore the rate increases. So talk about the powdered zinc carbonate has a larger surface area than large pieces of zinc carbonate. Okay, then next you talk about with a larger surface area, frequency of collisions between reacting particles increases, increasing the rate of the reaction. Okay. Okay, next, suggest what is observed when the solution is saturated in step 3. So when you have a saturated solution, how do you know that you have a saturated solution? Well, this is when you see crystals being formed. Okay, next, the formula of zinc sulfate crystal is NSO4.7H2O. Give the formula of the solid form if the crystal are heated to dryness in step 3. So if the crystals are heated to dryness, okay, instead of allowing it to crystallize, you will not have this water of crystallization. So if you do not have this water of crystallization, it's basically just ZnSO4. So the formula of the solid form when the crystals are heated to dryness is ZnSO4. Okay, no water of crystallization. Okay, now moving on to question 7. Okay, so in question 7, the periodic table can be used to classify elements. Group 1 elements react with cold water to form alkaline solution. Place the group 1 elements, calcium, lithium, potassium, rubidium, and sodium in their respective order. Put the most reactive first. So the most reactive one is the one that's lowest down in the periodic table, because the reactivity increases as you go down the group for group 1 metals. Okay, so if you were to check, so we have calcium, lithium, potassium, rubidium, and sodium. So let's go to the periodic table on the last page of the paper. Okay, so we know that we have calcium, rubidium, potassium, sodium, and lithium. So calcium is the lowest down. The option they don't give you francium, they give you calcium. So calcium is the lowest down, so it is the most reactive, followed by rubidium, then potassium, then sodium, and finally lithium. So let's write the answers here. Okay, so the most reactive one will be your calcium, followed by rubidium, then your potassium, then sodium, and then lithium. Okay, next, name the alkaline solution when calcium reacts with cold water. So when you have group 1 metal reacting with cold water, the alkaline solution form is something hydroxide. So because it is calcium reacting with cold water, the alkaline solution form will be called calcium hydroxide. Group 1 elements have a lower melting point than transition elements. Describe what are the differences in the physical properties of group 1 elements and transition elements. So you can talk about the group 1 elements have a lower density, or they are softer than transition metals. Okay, group 1 elements have a lower density than transition elements. Okay, or you can also write group 1 elements are softer compared to transition elements. So this is basically just the properties of transition elements versus the properties of group 1 elements. All right. Next, let's look at Group 7. Group 7 elements are known as the halogens. Astatine is below iodine in group 7. Predict the physical state of astatine at room temperature and pressure. So recall that as you go down the group for group 7, the melting point and the boiling point increases. So if iodine is a solid at room temperature, so astatine will also be a solid because astatine will have a higher melting point than iodine. So some group 7 elements react with aqueous solution containing halide ions. When aqueous chlorine is added to potassium bromide, a reaction occurs and you are given the ionic equations. So describe the color change of the solution. So the original color of potassium bromide solution is basically colorless. Okay, and at the end of the day, so initially you start off with chlorine, which is yellow, okay, and potassium bromide, which is initially colorless. Then finally you have chloride solution, which is colorless, and your bromine solution, which is reddish brown or brown. Okay, so you can say that it's brown. Depending on its concentration, it can also be orange or yellow, right? Okay, next you're asked which one is being oxidized. So if you want to look at oxidation in terms of electrons, and we know that oxidation is the loss of electrons. So in other words, we know that bromide is being oxidized. Okay. Okay. So we can write that bromide ions loses electrons to form bromine. So therefore it is being oxidized. Or you can also explain it in terms of oxidation number. Okay. So another explanation you can say is that the oxidation state of bromine increases from -1 in bromide ions to 0 in bromine. So therefore, because there's an increase in oxidation state, okay, therefore it is oxidation. So you can explain it in terms of electrons, you can explain it in terms of oxidation state, both are correct. Okay, next you are given bromine monochloride, so is BrCl, is made by the reaction between bromine and chlorine. The chemical reaction is given here. Calculate the overall energy change for the reaction using bond energy. Use the following steps. So first, you're asked to calculate the total amount of energy required to break 1 mole of Br2 gas and 1 mole of Cl2 gas. So to break Br2 and Cl2, you're basically breaking 1 mole of Br and 1 mole of Cl. So the amount of energy involved in bond breaking will be 190 plus 242 kilojoules per mole. So let's add that up. Okay. Total amount of energy required, okay, will be equals to plus 190 plus 242, which gives us a value of plus 432 kJ per mole. Okay, so it's 432. Okay, because they say every 1 mole, so don't need the per mole. Okay, so it's 432 kilojoules. Next, we form 2 moles of BrCl. So we have 2 BrCl being formed. So the total amount of energy released, okay, is basically 2 times 218. Okay, which gives us a value of 436 kilojoules. So next, calculate the total energy change for the reaction. So to find the energy change, you will take the amount required for bond breaking minus the amount released. Okay, so minus this amount of energy involved in bond forming. So the energy change, okay, or if you don't want to write, you can basically just write it as delta H for this reaction. So delta H is basically, just remember bond breaking is positive, so it must be a positive sign. Bond forming is negative, so it must be minus. So we know that it will be minus 4 kilojoules per mole. So it's minus 4 kJ per mole. right? So that's it for this paper here.